So in our video today, we are going to calculate the sum of the following series. Now we've already calculated the sum of an arithmetic series which had a start and then it also had an end. Now if we were to look at this one and check if it can be arithmetic, we say term number 2 minus term number 1, it gives us 0.25. And then if we say 1 minus 0.5, it gives us 0.5. Clearly, the first difference is not common, so it's not an arithmetic sequence. So if it's not an arithmetic sequence, let's try to check if it can be arithmetic by saying term number 2 divided by term number 1, which is going to be equaling to 0.5 divided by 0.25. And then it gives us a 2. Now we can also check term number 3 divided by term number 2, which is 1 divided by 0.5. It gives us a 2, which clearly tells us that it's a geometric series. Now, since we're dealing with the geometric series, we have a summation formula that we can use for a geometric series. Now, first and foremost is that we are told to calculate the sum of the series, but we don't know how many terms are there. Now, from our previous experience, we know that we are given the last term, which is 2, 5, 6. So we can try to get how many terms are there in this series. So we have Tn, since it's a geometric, not arithmetic, we have A, R, N minus 1. Now if we were to substitute our last term, 256, which is going to be, in this case, our first term is 0.25, and we have multiplied by our R, which is 2, and then we have N minus 1. Now we're simply going to try to divide by 0.25 both sides. Now if we divide both sides by 0.25, it gives us 1024, which is going to be 2 to the power of n minus 1. Now clearly we have done an example like this one. If we have something like this and then we're dealing with exponents, we're going to change it into a prime product. If we change this into a prime product, it says that it's going to be 2 to the power of 10, which is going to be equaling to 2 to the power of n minus 1. Now, since our bases are equal, we can say that our exponents are also going to be equal. So we drop our exponents, then we have 10, which is going to be n minus 1. Take the 1 to that other side, then it says our n should be equaling to 11. So basically we are adding the sum of the first 11 terms. Now with that being said, we have the following formula to calculate the sum, which says Sn is going to be equaling to A, then we have an open bracket, then it says we have R to the power of n, then we have minus 1, then we close the bracket, all over R minus 1. Now, based on what we have, we're looking for S11. So we have S11, which is going to be given by our first term, it's 0.25, open bracket, our R is a 2, then we have to the power of 11, everywhere we see n, minus 1, now all over 2 minus 1. Now if we were to type the following in our calculator, we get an answer that it's 51175, and then that's how we calculate the sum of a geometric series if we don't know how many terms are there, but we're given the last term.